First of all, I want to thank the organizer for their kind invitation to be present here. I will speak about what is the role of Academy of Sciences in this climate change issue. The mainstream is United Nations, IPCC, governments. This is the mainstream discussing mitigation, adaptation to climate change. Academies of science, most of them are non-governmental organizations that are at the side of the government. But I think we have a role in all this, perhaps a small role, but an important one. The first role of Academies of Science is to promote education on the climate change issue. We are involved in courses and talks addressed to students of primary and secondary schools, journals and the media, and the general public. I mean, this is, for me, a very important role for Academies of Sciences. In fact, in the UN Sustainable Development Goals, number 13 is related to climate change, and 13.3 is improve education, awareness raising, and human and institutional capacity on climate change mitigation, adaptation, impact reduction, and early warning. And then we are working on this 13.3 assessment. I want to say that the IAP, Inter-Academic Partnership for Science, that includes 130 academies of science, medicine, and engineering from around the world, has a new and important project on climate change and education. And I will read the headline messages of this IAP. Is education, especially science education, must play an essential role in preparing present and future generations to understand climate change and be prepared adequately to adapt and mitigate its impacts. Inquiry-based science education, developed over the last 2 decades, has demonstrated an effective way to teach science at primary and secondary school levels and also to inspire higher education worldwide. It provides a firm basis to develop urgently a specific interdisciplinary climate change education program. Just another statement, climate change education must consider the need to provide teachers in developed as well as in developing countries with up-to-date facts, new and innovative training processes, new resources for their classroom, and new tools to empower their students as agents of change. Climate change and associated events will disproportionately impact the poorest 3 billion of the global population, whose schooling is far from adequate. Climate justice calls for supporting their schools and their teachers with specific initiatives. International collaboration through the involvement of the science community will greatly enhance the mobilization of educational systems. As the IPCC is producing periodic assessment reports accompanied by summaries for policymakers, the scientific community should use the material from the IPCC reports to produce resources and tools for teachers. Okay, also, apart from educating young people, I mean in primary and secondary schools, we have to educate people, politicians, and the media about the significant risks that the world will face in the next decades. An important issue is also to educate people on the importance of reducing the energy demand by increasing energy efficiency. This is considered the most important action to reduce greenhouse gas emissions. I was told that the best energy we have is the one that we do not consume. And this, the importance of reducing, of improving energy efficiency is very, very important. This is the education part, but we have other roles of academies of science and scientists. A clear role is to promote research and development on cleaner fossil fuel technology and the transfer of resulting knowledge to the whole world. This is just one example. There are a lot of examples coming from science to impact on climate change, but this is a very important one. Goal number 7 of the UN Sustainable Development Goals states that it is imperative to ensure access to affordable, reliable, sustainable, and modern energy for all. I mean, this is energy for everyone. It is a universal right to have access to affordable energy. What is the situation? This is the naive point of view of a scientist. I took some figures, I put them there, and this is my conclusions. The goal of a universally access to energy. I listed the energy consumption per capita in arbitrary units of 5 countries. In the middle, I put 2 European countries, representative of the European Union, Germany and France, that I put the energy consumed per capita is close to 1 in arbitrary units. USA consumes 80% more, China half, and India 1/8. The problem is that USA, the emissions, the actual emissions of China, the first one is 10.6 gigaton per year. USA is half, 5.2, and India is the third one, is 2.5 gigaton per year. And they represent 50% of the emission in the world, of CO2 emissions in the world. If you read forecasts for energy demand, the forecast is that they will increase 37% by 2040, with most of the rise coming from Asian countries, particularly China and India. And it is clear that if they want to have the standard of living of Europe, China has to multiply by 2 the energy consumption, and India has to multiply it by 8. And look at the emissions. Another problem is the immense reserves of shale oil and shale gas indicate that fossil fuels will be used for energy production in the next decades. This is my personal naive opinion. World reserves of shale gas. The first one is China, the second is Argentina. It's a revolution in Argentina with the use of shale gas and shale oil at this time. The third is Algeria, and the fourth is USA. And shale oil is non-conventional gas and non-conventional oil. Russia is the first one, USA the second, China the third, Argentina is the fourth. Then these new sources of fossil fuels will be used in the future, in spite of all of the increases in renewable energies that we have now in these countries. Then an important question is we need to develop and transfer advanced and cleaner fossil fuel technologies. For me, this is a very important point. Just to give an example, in the MIT Technology Review of this year, there are 10 breakthrough technologies, and one is zero carbon natural gas. Around 22% of world electricity is produced with natural gas. A power plant was developed, that it was the breakthrough technology, that efficiently and cheaply captures the carbon dioxide released by burning the natural gas. Then this is a pilot plant that is evolving to an industrial production in the USA, but anyway, there might be another examples in the literature. But the idea is that now science provides, and technology provides a way to capture the carbon dioxide that is generated in a thermoelectric power plant using natural gas. You can generate electricity and capture all the carbon dioxide that is generated. But the problem is necessity of developing significant markets for the carbon dioxide to push down costs. In this sense, then we need a gigaton scale market for carbon dioxide. And we can look at artificial photosynthesis. Plants use sunlight with 1% efficiency of the received solar energy to convert carbon dioxide and water into carbohydrates that power cellular activities. Today we heard an exposition saying that it is very important to increase the efficiency of plants, and it is an important issue. Several processes are being developed to make a similar process artificially. A recent paper published in Science in 2 years ago, reported the synthesis of a liquid fuel using carbon dioxide, water, and sunlight with 10% efficiency of the solar energy. The key is the use of a specific bioengineered bacteria that convert hydrogen obtained from water and carbon dioxide into a liquid fuel. Other approaches employing inorganic catalysts. The idea is here. This is just a laboratory experiment published 1 year ago with a quantum yield of 12.4%, where we see you can convert CO2 and water using solar energy into methane back again. You have the methane evolution as a function of time. And then, just as an idea to be developed in the future, you use natural gas to produce energy, but then you produce water and CO2. You can then use the CO2 that was produced, but now you need energy to convert it back to methane, and this is solar energy. You regenerate methane, and then you can convert methane into energy, and so on. This is just basic science at this time, but if you can combine CO2 capture with artificial photosynthesis at a larger scale, we have some of the problems can be solved. Other markets for carbon dioxide are, there are several: food and drinks, plastics, carbon nanotubes, mineral carbonates, etc. There is also another important market that can use CO2 is in cement and concrete technologies. Cement production accounts for about 5 to 10% of global CO2 emissions. An advanced technology has been developed that captures and uses CO2 emissions in concrete production. It uses existing concrete production equipment and Portland cement chemistry to react with CO2, producing an in situ nano-sized mineral carbonate embedded within the concrete. It enhances material properties without impacting the normal plant operation. That is, you use CO2 in a larger scale, you produce nano-sized minerals that improve mechanical properties of the final product, and this is a source to capture CO2 instead of sending it to the atmosphere. This is, I think this is the last one, just to give it some other examples of my own country in Argentina. The government has a plan to go ahead with the IPCC to reduce CO2 emissions. Then there are a lot of new plants operating with the eolic energy and solar energy. This will improve the actual incorporation of these renewable energies into our energy matrix. But now it is 10% of renewable energies. It will increase to 20% in the near future. That is the compromise with the IPCC. One more example, and I finish with this, is we have strong winds in the Patagonia for producing eolic energy. But the problem is that Argentina is a very huge country, and then we have to transmit this energy to Buenos Aires, and this is very expensive. Then the idea there will be a plan is to use the wind to produce hydrogen. It has been explained. Then you have electrolysis, hydrogen. Then we have to develop a local market for this hydrogen, and then to see if it is possible to export it, for example, to Japan from ports in Patagonia. But then we need, what Professor Chu said before, is we need some kind of storage hydrogen for being transported by the sea. What we are now doing is to use this future production of energy to make an important plant that makes urea, and then instead of producing hydrogen by reforming of methane, we will use this hydrogen for industrial production of chemicals. This is part of the stories that we're developing in the country. And thank you for your attention.
Yeah.